should be good to go.
Good morning, everybody. Thank you so much for joining us today for Dome to Home. My name is Tara, and I'm a planetary scientist and a presenter here at Fiske. We also have Parker here. He's our navigator. He's going to be our spaceship captain for today. He'll be flying us around and showing us all kinds of awesome stuff. And it's all done live. Everything that you see on the Dome interface here on our right, all that's being controlled by Parker. And we also have our friend Emily here with us. You've heard from Emily a little bit in the chat already. She's not on camera, but she's going to be monitoring that chat window and keeping tabs on any questions that you might submit during the talk. So if you have a question, chat it in there. We'll try to get to as many of them as we can. I will try to answer some as we go, but then we do have time dedicated at the end for some questions. So we are especially excited about the program today because today is Earth Day. Happy Earth Day, everybody. This is actually the 50th anniversary of Earth Day. It's super exciting. So today we'll be talking about a common Earth Day theme, the atmosphere. But not just Earth's atmosphere, we're also going to look at the atmospheres of Venus and Mars and maybe even some exoplanets. But let's start at the beginning. So I'm sure you know what an atmosphere is, but do you know where atmospheres come from? How do we get an atmosphere to begin with? You guys have any ideas? Chat them in there. Nobody? All right. Nope. All right, that's fine. So let's talk about where atmospheres come from. So one of the ways that a rocky planet like Earth can form an atmosphere is through a process we call outgassing, which is just like it sounds, letting gas out from inside the planet. When planets form, they have a lot of gas inside that's trapped in the rocks. And the pressure at the center of the planet increases, things start to heat up, it melts those rocks, which releases the gas. And some of that gas will stick around the planet thanks to the planet's gravity. And over time, this can continue to happen. And as more melting happens inside the planet, you get more gas released. The prime way that this happens is through volcanoes. That's how we get most of this outgassing, all of that magma coming out and becoming lava on the surface, releasing all those gases. Also hydrothermal vents in the bottom of the ocean. That's another great way for outgassing to happen. Gases can come up through the ocean floor, infiltrate, stuff like that. So another way that we can have atmospheres and gases delivered to the Earth is through asteroids and comets. So those often have gases and ices and things trapped inside of them. And they're pretty small once they actually get through our atmosphere and down to the Earth. Those rocks are generally not very big, but they do still have some gas. But the cool thing is there's a lot of them. So even though they're very small, they don't deliver a lot of gas. There's tons of them. So let's say we're here on Earth. You see in the dome here on the right, you can see we're looking up at the sky. There's the sun there, the moon right with it. Let's see, let's go, Parker. Can we move till later in the evening? We'll get rid of that one big star that's in our way so we can see all of the other stars. So our sun is moving across the sky. Moving into nighttime now. All right. So here's our night sky for us. Right now it looks a little yellow. They've got light pollution here in Boulder or Denver or anywhere around here. We've got a lot of lights in the sky. But we'll move away from that so we get some more stars. And Parker, let's see, where are asteroid belt is in our sky. Can we turn on the asteroid belt?
Yes.
Sweet.
There we go.
Okay. So there's a ton of asteroids in between the Earth, or sorry, in between Mars and Jupiter. That's where our main asteroid belt is. So we have tons of little rocky bodies that are coming and hitting the Earth from there. But there's also a group called the Kuiper Belt, which is outside the orbit of Pluto. And that's another huge reservoir of asteroids and comets, mostly icy stuff. Let's turn on the Kuiper Belt too.
Mhm. Well, let's see if it will actually turn on.
So the Kuiper Belt has tons and tons and tons of icy comets and things like that. And then even beyond that, there's a whole other giant reservoir of comets and asteroids called the Oort Cloud, which is way, way, way far out, extends out to 1 trillion miles from the sun, yet it's still held to our solar system by the sun's gravity, which I think is crazy. Yeah, so there's even more of those. So there's tons and tons and tons and tons of little comets and asteroids that can come and interact with the planets in our solar system or slam into the Earth and bring us those atmospheric elements that we're looking for. So those are the primary ways that a planet can get an atmosphere. But obviously, you know, the atmospheres change over time too. In fact, how about, Parker, what do you say we leave the Earth entirely and check out our solar system from a little farther out? All right, we're blasting off here. Everybody hold on. All right, so there's our big, beautiful Earth underneath us there. So, like I said, you know that our atmosphere can change over time, and I'm sure you know that humans have made a huge impact on our environment. We are really good at releasing greenhouse gases like carbon dioxide, and CO2, carbon dioxide, is one of the most powerful greenhouse gases there is. Now, Earth's atmosphere naturally has some carbon dioxide in it, but that's it's not nearly as much as there is now. But CO2 in the atmosphere is not necessarily a bad thing in moderation. That's what gave rise to plants here on Earth that can breathe CO2 and breathe out the oxygen, which in turn lets oxygen breathing animals like us exist. So we like that. By the way, did you guys know that the most effective greenhouse gas that there is actually water vapor? Water vapor is the strongest greenhouse gas that you can have, but it's also kind of fragile. So there's a ton of water vapor in our atmosphere that's acting as a greenhouse gas, but it breaks apart really easily when it gets hit by sunlight. So it can break apart into other elements, it can evaporate or solidify or rain out. So the water in our atmosphere doesn't last very long. So even though it is a really powerful greenhouse gas, it's not nearly as persistent as some of the other ones that we're used to hearing about, like CO2. CO2 is much, much harder to destroy, so it sticks around in the atmosphere a lot longer. And that's why it's able to build up and cause so much damage. So Earth's atmosphere is in a really delicate balance. So having just the right amount of greenhouse gases is important for regulating the temperatures here at Earth, making it a good place for us to live. See, Parker's put up a map on the Earth here. The red areas are where it's really high in CO2. Blue areas are a little bit lower. And this is running over time. So if you watch it, you'll start to see more and more of the reds and yellows. See how it's getting really nasty there at the bottom? So that's our CO2 in our atmosphere. And like I said, that helps kind of keep the Earth warm, so it's comfortable for us to live. But of course, our atmosphere isn't the only thing that influences what makes Earth habitable. Our distance from the sun has a lot to do with it as well. So let's back out even a little farther so we can see where our Earth is in relation to the rest of the solar system. See lots of questions coming through the chat. You guys are on it. Ooh, I like this one. Is COVID-19 helping global warming? That's a question from Avalon. And Avalon, it actually is in a lot of areas because a lot of people are staying home more. They're not out driving their cars or going to work. Lots of factories and things are closed down. So there's a lot less of those CO2 emissions that come from cars and factories and things like that. So you can go, there's a couple of places online where you can go and find comparisons. I know the NASA website has some. I believe National Geographic have some too. We can try and find some of those links for you later. But they have really cool comparison maps of CO2 emissions before the pandemic and now. It's really cool. It's a really great question too. All right, so here is our solar system. You can see the sun in the middle. There's the orbits of all the planets going out from there: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So those are all of our major planets that are right in close to the sun. So you'll notice that our sun it's pretty close to our star, but it's not terribly close. And stars, of course, are really, really hot. They put out a ton of heat. So for life as we know it to exist, a planet has to be in just the right spot. It can't be too close to the star where it would be too hot, can't be too far from the star where it would be too cold. It's got to be just in the middle, just right. So we call this the Goldilocks zone. Not too hot, not too cold, just right. And I think we've got a cool picture that we can show you of what it looks like in our solar system. So you can see the part on the bottom is our solar system. You can see Mercury's in the too hot zone. Even Venus is right on the edge. Mars is out towards the too cold zone. Earth is really the only planet we have that's right in that green area, right in the Goldilocks zone. So that's Earth, but I promised you guys 2 other planets too. So let's take a look at these other 2 planets that are right on the edge of that habitable zone. We've got Venus and Mars on either side of us. So first let's go to Venus. We're gonna move closer to the sun. So we expect it would be probably warmer. Lots of excellent questions about habitability. I think we'll save some of these to the end because they are really kind of complicated answers. So we're coming up on Venus here. Should see it in just a second. Here it comes. See the little dot. All right. So here we are at Venus. Let's get some light on there so we can see what it looks like. Brilliant. All right, so this is Venus, more or less. One thing that you might notice right off is that you don't see any like oceans or continents or really anything at all on Venus yet. When you look at Venus, you'd actually just see its atmosphere. Venus has such a thick atmosphere that you can't actually see down to the surface of the planet. All you can see is clouds. And those clouds are a little bit different than the ones we have here on Earth as well. Venus's atmosphere is made up of 90% carbon dioxide. It's almost all CO2. And the rest of it is clouds of sulfuric acid. So it's super nasty, super, super gross there on Venus. And so it makes it really difficult for us to study it. And we don't really know a whole lot about Venus itself. Now, thanks to the Russians, we do have some cool images of the surface of Venus. In the 1970s, the Russians sent the Venera landers, Venera is the Russian word for Venus, down to the surface. They sent like 15 of these things, and really only 2 of them landed. And they lasted just long enough to take some pictures and make a couple of measurements, and then they died. Because Venus's atmosphere is so thick and so full of carbon dioxide, it's really, really hot on the surface. It's closer to the sun too, so it's already getting more heat from the sun, but all of that carbon dioxide is trapping almost all of the heat that it does get down at the surface. And so temperatures on the surface of Venus are about 800 degrees on average in Fahrenheit. So these poor little robots that they land there don't have much of a chance of standing up to that, but they did send us some cool pictures. You can see here, Venus, the surface is really kind of rocky. There's a lot of dust. That's really all there is to it. We don't see any evidence of liquid water or any sort of life. It would have to be a very strange form of life to live on the surface of Venus because of all that heat. And because that atmosphere is so thick, there's a ton of pressure at the surface too. It's about 90 times the amount of pressure that you feel here on Earth. So it's crazy out there. And we're still trying to figure out how this atmosphere came about. We don't really know. Nobody was around when all this was, being built up. We do think, though, that it was probably mostly outgassing. Again, just like the Earth has volcanoes that spew gas into our atmosphere, Venus, we're pretty sure, is still volcanically active. It still has volcanoes that are erupting, and it has a ton of them. In fact, when you look at Venus in a radar, you can actually see down through those clouds, and you get an idea of what the surface is like in terms of heat. Let's see if we can throw that radar overlay on there. Ooh, how many G's is that? I don't know the conversion off the top of my head. Ooh, that's a pretty color. We've got a really great map here that shows you all of the really hot areas on Venus. There's tons and tons of them. You can see hot spots, but you can also see cracks where it looks like there's maybe faults on the surface. Ooh, there's a great question from Abigail. Do any other planets have volcanoes? There are no other planets that have active volcanoes. There are moons that have active volcanoes. In fact, the most volcanic body in the solar system is one of the moons of Jupiter. It's super cool. Yeah, here's a great picture of Venus there. You can see all of those dark spots. Those are volcanoes. And we think that they're still erupting. We don't know for sure, because like I said, it's really hard to study Venus, but we're getting better at it. There's a couple of missions that are proposed right now that are going specifically to study Venus. One that's going to be like a balloon in the atmosphere, and then another one that's going to try and land on the surface. It should be pretty cool. Keep an eye out for those. We should know in about 6 months or so whether those are going to get selected. All right, so that's Venus. That's what happens if we have too much carbon dioxide in our atmosphere. You end up with high pressures, a lot of heat. Let's go the other way now and look at Mars, because it's kind of got the opposite thing going on. Let's see if we've got any other questions here. Why is the size of Venus and Earth identical from night to dawn? We don't know why, really. It's just probably just kind of chance. They formed around the same time, out of the same stuff. They probably had a similar kind of evolution from start to finish, so ended up about the same size, but it's probably mostly just chance. There's no real reason why. How does zero gravity mess with your insides? All sorts of ways. Like, have you ever hung upside down, like on monkey bars or something for a really long time? You start to feel kind of queasy and gross. Or like if you jump up and down, or like on a roller coaster where you can feel your stomach kind of lift up sometimes, it would be like that, but all the time. So like our astronauts that live on the space station, they have to go through a lot of training, and there's a lot of stuff that they have to do to prepare for living in a low gravity environment, because it will really mess up your insides. All right, so here we are at Mars. So Mars is a planet on the other side of us. It's farther away from the sun, so of course we would assume that it would be a little bit colder. And Mars also has the double whammy of barely having any atmosphere at all. Mars's atmosphere is only about 10% of the atmosphere that we have here at Earth. It's very, very thin. But we don't think that it was always that way. Most scientists now think that Mars probably once had an atmosphere that was a lot like Earth's, with lots of clouds and different gases, really thick. So Mars at one point may have looked a lot like the Earth, with continents and oceans and cool stuff like that. We don't know about life. There may have been trees and things. We haven't seen any evidence of that, but we think that Mars probably once at least had oceans and high areas and things like that. But something happened between formation and now that caused Mars to lose its atmosphere. There's a group here at CU that works at a spacecraft called MAVEN. And MAVEN is out right now specifically studying the atmosphere of Mars. Oh, here's a great little overlay. You can see where we think that Mars might have had oceans. You can see some continents there on the edges. You can kind of scroll around on there. So we're not sure what happened to cause Mars to lose its atmosphere, but something did. Now, the leading theory is that Mars lost its magnetic field at some point. And a magnetic field is something that's really important for protecting a planet from solar wind, which is just a whole bunch of charged particles that are constantly blowing off the sun. So if there's nothing to protect a planet from that, those particles can hit the atmosphere and knock all the atmospheric particles out into space. And so a planet can lose its atmosphere by something like that. We think that's probably what happened to Mars. We're not sure, but we're still trying to figure that out. We don't see any evidence for liquid water on Mars now. Mars is way too cold. The surface temperatures there around the equator can occasionally, in just the right circumstances, get above zero. But for the most part, it's about -80 degrees on the surface of Mars. So not a really fun place for people like us to live, but we're still looking for things like microbial life, things like that, little critters that could be under the surface perhaps, things that could live in the ice. Mars does have a lot of ice. You might have seen while we were scrolling around on Mars, it has ice caps, just like we have here at Earth at its north and south poles. Except it's so cold that the ice caps aren't just made out of water ice like ours, they're also made out of carbon dioxide ice, CO2 ice. You might have heard it called dry ice. It has to be really, really cold for there to be carbon dioxide ice. So that's one of the reasons that we know that Mars is very, very chilly, not a friendly place to live. Ooh, does Mars have seasons? Mars absolutely does have seasons. In fact, pretty much any planet that rotates has seasons. Mars also has really cool seasonal dust storms. It has enough atmosphere that it gets these crazy big winds that pop up. And so they'll have dust storms that can cover the entire planet for like weeks at a time. It's really crazy. Messes with our instruments. It's really hard to study Mars when there's all these crazy things going on like that. So that's kind of how the Goldilocks zone in our solar system works. Earth is in the middle, Mars and Venus are out on the edges, a bit questionable. But that Goldilocks zone is different depending on the star you're looking at. It's different for a star that's not our sun. So let's pull that picture back up so you can see where ours is, and then there's another one on top of it. Yeah, this one on the top is for what we call the Trappist system. This is a system of planets going around another star, a star that is not ours. So this star is called Trappist. It's a very, very tiny star, And so its Goldilocks zone is much closer in. And you can see it's got lots of planets in that zone. There's like 1, 2, 3 at least that are in that green area. So we're looking right now and finding that there are a ton of planets out there. We have a couple of dedicated telescopes that are specifically looking for these exoplanets, we call them. There's planets going around stars that aren't ours. Now, how we find those is we actually look at the star. It's really hard to see a specific planet going around a star that's maybe hundreds of light years away. Planets compared to stars are really, really tiny. So this telescope that Parker's got a picture up here, this is called Kepler. Kepler was the first big exoplanet telescope that we put up about 15 years ago, I think. Kepler went up, he was the OG, just pointed at different stars all across the universe, trying to find planets. Now, like I said, it's really hard to see a planet next to a star because they're very tiny. So we use something called the transit method, which basically what we would do, Kepler would stare at a star for a really long time and wait for a planet to pass in front of it. So as a planet passes in front of that star, it's going to block some of the light from the star. So while Kepler can't see the planets themselves, he can see that the light from the star will dim a little bit. And so, of course, big planets will block more light, so it'll dim a lot more. Small planets don't block quite as much light, so just a little dip. But you can tell by those dips that there's a planet going around there. So this transit method is how we find most of these exoplanets that are out there. And Kepler was out there for like 10 years, and pretty much every star that it pointed at, it found at least one planet going around. Sometimes there were 2 or 3 or 7, but pretty much every star out there has a planet going around it, which is really exciting. Now we have a new telescope that we just put up called TESS, the Transiting Exoplanet Satellite Survey. TESS will go up there. It's got much better technology, much better telescope, so it can see as these planets are moving in front of the star. It not only sees that light dip, but it can see the light coming through that planet's atmosphere, if it has one. Yeah, there you go. There's a good picture of it. So you can see the little blue planet moving in front of the sun. It's got that kind of jaggedy atmosphere going around the outside. So the light coming through that atmosphere allows us to, A, see that there's an atmosphere there, and sometimes we can even tell what it's made out of, which is crazy. So that's a big thing that's starting to happen right now. This is all new. So we're starting to figure out that, yes, these exoplanets do have atmospheres. Sometimes we can even tell what they're made out of. And we have even found 1 or 2 that have water vapor in their atmosphere and clouds and things just like we have here on Earth. So we don't have any confirmation that there are Earth-like planets out there, but we do see a lot of promise, and we're getting better at finding them now. So definitely stay tuned to see what we're going to find with these exoplanets in the next few years. And on that note, we are getting close to our time here, so I do want to jump in and get a couple of these questions answered for you guys. Let's see, here's a good one from Samuel. What would happen if the atmosphere just disappeared? You're absolutely right. Humans would not be able to live. That would be a serious bummer. Pretty much everything on the planet that breathes is going to have a really bad time. Without an atmosphere, we're also going to lose that sort of insulating blanket that we have, so the temperatures on Earth will drop significantly. I think those are probably the 2 main things that would happen if our atmosphere just went away. It would get really cold really fast, and that's bad news for us. Good question there. What else do we have? All right, I'm looking. Have we discovered life on another planet? Not yet. We're still looking. And that gets really, really complicated because life, we don't really have a good definition for it. We can look for life that's like us, things that, are carbon-based, breathe oxygen, need to live at certain temperatures, but that might be a very narrow definition of life. There could be things that are alive that are completely different than us. I mean, we could look at it and think, oh, it's just a rock, but maybe it's actually alive. So finding life on other planets is really, really tricky because it depends on your definition. So we definitely haven't found any life like us anywhere, but that's kind of the best we have to go on so far. Let's see. When is the Earth going to die? That depends. It depends on if we keep messing with our atmosphere or not. If we keep destroying the atmosphere, the Earth might die a little bit quicker than it would otherwise. But assuming that's not a problem, the Earth is going to be around at least probably another 4 or 5 billion years. The only thing that we know of that is definitely going to kill the Earth is when the sun dies. When the sun gets to the end of its life, it's going to basically explode. And that's going to be bad for pretty much any of the planets out to Mars. All of us inner planets are going to be in big trouble because we're going to get just blown up by the sun. But our sun's kind of middle-aged right now. It's not supposed to die for another 4.5 or 5 billion years. So we should be good for the time being. Will black holes eventually consume the universe? Probably not. Black holes are not this like giant sucking monster that people kind of think they are sometimes. They're more like the bottom of a funnel, kind of. They have a specific radius to where their power cuts off. They can't just keep sucking things in from everywhere. They can only suck things in up to a certain point. So unless something happens to where we're just full of billions and billions and billions of black holes that are all really close together, we're probably pretty safe. Black holes do eventually die, we think. We don't really know. We've never seen it happen. Again, really hard to study black holes because we can't actually see them. But Stephen Hawking has a theory that they do sort of evaporate over time. They have a little bit of radiation that's coming out of them. This is just a theory. We haven't seen it yet, but he did think that over time, this evaporation could eventually lead a black hole to disappear completely. We don't know for sure yet, though. Let's see. A story about a small black hole hitting the Earth 100 years ago? Could be. We don't really have any evidence for that. That's kind of the best. It could have happened. If it was very small, we may not have even noticed it. Generally, these things like micro black holes that you might hear them talking about last fractions of a second. So even if a tiny black hole did pop up really close to the Earth, it would probably immediately disappear as well. Let's see. If we end up finding another habitable planet, will we move there to live longer? Maybe. That would be cool. Problem is, all of these exoplanets that are outside of our solar system are really, really far away. So the closest star to Earth is almost 5 light years away. So if you traveled at the speed of light, it would still take you 5 years to get there. And we can't travel anywhere near the speed of light, not even like 1%. So we would either need to really boost our travel capabilities, or just be really, really patient, because it will take a very long time to get to another habitable planet. And that's just the closest one. So that's kind of the problem we have now. Even if we do find these planets, we don't know how to get there yet. So keep doing your math and physics homework. Figure out a way that we can travel faster than light, and then we'll see. Let's see. Is there any other moon, dwarf planet, or planet that we can live on? Not that we could just show up at. We would have to do a bit of at least building on other planets. Like, people want to talk about putting people on the moon, sending people to Mars. These are things that are possible, but these places are not instantly ready for people. It is not a place that would be really comfortable for us. So if we did show up there, we'd have to build a lot of habitats and things like that. We couldn't just show up and be like, we're here, and take off our helmets. It would not go well. But there are places that are more reasonable for doing something like that, places like the moon and Mars that are close and easy for us to get to. There are some other moons out in the outer solar system that have some really interesting properties. Several of them actually, that have oceans underneath their surface. So there's tons of liquid water there. There's one of the moons of Jupiter that's really big and doesn't have a lot of radiation on it. So that's another really interesting prospect. But again, for us to live anywhere outside of the Earth, it's going to take a lot of work, not just to get there, but once we get there, to make it livable. Excellent question, though. All right, I think we got time for like one or two more. Will Earth lose its magnetic field like Mars? From Eli. We don't think so. Eventually, it might. Now, we're not sure why Mars lost its magnetic field to begin with, but the leading theory is that it has to do with Mars being small. Mars is about half the size of the Earth. It's a really small planet. And when planets form, the way that they have that magnetic field is that they're liquid on the inside. Like Earth has our crust on the outside, then there's sort of the liquidy rock mantle and the core on the inside that's made up of iron and metal, and part of that core is still liquid. So it's that liquid core that's moving and interacting with things around it that generates the magnetic field. Parker's put up a great picture here. I love this. This is the Earth, and all of those lines are kind of what our magnetic field looks like, or what it would look like if you could see it. They're invisible lines. You don't actually see that, but that's what it would look like. So it's these hot liquid metal cores that are generating the magnetic fields. But over time, planets do cool down. They're really hot when they first form, but then they'll start to cool, and they cool from the outside in. We always say it's kind of like a baked potato, like it'll get cold on the outside, but it'll still be hot on the inside. And just like with baked potatoes, a big planet is going to cool a lot slower than a small planet. So a small planet like Mars can cool off a lot faster, that core will solidify, and then it can't generate the magnetic field anymore. So we're pretty sure that's what happened to Mars, is that it just cooled off, it lost its ability to make a magnetic field. So eventually that could happen to Earth. Earth is still really hot on the inside, and so we've got a good field going, but eventually it could cool down enough that we'd stop having that, what we call a dynamo, that's generating the magnetic field inside. How long that takes, I don't know off the top of my head, and I'm not sure that it would be before our sun explodes. It's kind of a toss-up. So physically, it is possible, but I don't think it's very likely. Definitely not anytime in the near future. So we're safe there. All right, guys, we got 2 minutes. If anybody has any burning questions that they want to jump on here. Can we harvest a black hole's energy? From Christian. Not with our current technology. Is it physically possible? Maybe. Black holes are really complicated, and it's really hard to get anything out of a black hole. That's why they call it a black hole, because its gravity is so strong that not even light can escape it. So really, we don't see a lot of energy coming out of black holes in general, unless they're those super, super, super massive ones. And to get anything out of that is going to be really challenging, because you can't get too close to it. It will pull you in if you get too close. I think if you got close enough to try and harness energy from it, you might actually end up being pulled in. And even if you weren't, if you're getting far enough back to where you're not getting pulled in, there's all sorts of other stuff that's moving around too. Yeah, there's a great picture of how the gravity works kind of around a black hole. There's that horizon called the event horizon. That's kind of the edge of where a black hole has its influence. So if you're staying outside of that, you'd probably be pretty safe, but there's also tons of other stars, gas and dust, meteors, asteroids, everything else is being swirled around there too. So it's probably not a very fun or easy place to live and hang out and do science. So as far as harvesting the energy from one, we would need a lot better technology to make that work. But it is an interesting idea. I would be interested to see somebody write that up. I like it. All right, guys, and with that, we are out of time for today, but thank you so much for joining us for Dome to Home today. Be sure to come in next week, too. We're doing a show about 30 years of the Hubble Space Telescope. So we're going to have lots of really cool pictures of galaxies and planets and nebulas and all sorts of awesome stuff like that. So just a reminder, these are all recorded and will be available on the YouTube channel afterwards. So if you want to come back and watch later or share with your family and friends, check us out back here. If you did have any questions that we didn't get to, you can comment those as well, and we'll try and reach out as best we can. Otherwise, join us again next week. Thank you so much for coming. Same time, same channel on Wednesday at 11. Hope to see you then. So for me and Parker and Emily, we'll see you next time.
Bye, everybody.